Across the infinite canvas of the night sky, humanity has always asked one question: are we alone? It's a question that predates history. A question whispered around ancient fires, etched into cave walls, echoed in temples, whispered into telescopes. From the earliest stargazers of Mesopotamia to modern astrophysicists at NASA and CERN, this single, haunting question has haunted the mind of our species. And now, for the first time in human history, we may be standing at the threshold of an answer. A new chapter has begun. One not written in ink, but in light. The James Webb Space Telescope, humanity's most powerful eye in the cosmos, has picked up something unusual. Something subtle, but impossible to ignore. A flicker. A pattern. A whisper of light, from a world that may not be alone in the dark. Let's pause. Let's breathe in the scale of this. We are a single species, clinging to a pale blue dot, adrift in a galaxy of over 100 billion stars. And that galaxy? Just one of 2 trillion in the observable universe. Every pinprick of light in the sky could host planets. Every planet could host water. Every drop of water could harbor life. And now, we may have found something that changes everything. It orbits far beyond the Moon, in a gravitational sweet spot called the L2 Lagrange point, shielded from the Earth's heat, sound, and light. The James Webb Space Telescope, JWST, is not just a telescope. It's a time machine. A light catcher. A cosmic oracle. It sees not just visible light, but infrared, allowing it to pierce through cosmic dust, revealing newborn stars, ancient galaxies, and now, possibly the fingerprints of an alien civilization. When JWST turned its gaze toward a nearby star system, Proxima Centauri, what it saw was subtle, but unmistakably strange. On its rocky planet, Proxima B, there may be artificial light. Just 4.25 light-years away, Proxima Centauri is our closest stellar neighbor. A dim red dwarf, barely visible without a telescope. Orbiting it is Proxima B, a rocky planet just a bit more massive than Earth. It lies within the habitable zone, where liquid water could exist. Where the temperature might just be right. Where life, as we know it, could take root. But there's a twist. Proxima B is likely tidally locked, one side in eternal daylight, the other in permanent night. Imagine that. A world split in 2. One hemisphere scorched by endless sunlight, the other plunged into a frigid, eternal shadow. And now imagine this. What if a civilization evolved on the night side? They would need light. Energy. Heat. And they might get it by harnessing power from the sunlit side, via vast solar panel arrays, and beaming it to the night. Just like we power cities from hydro dams miles away, they might illuminate their world with technology. And that light, if strong enough, could be seen from Earth. In 2021, astrophysicist Dr. Manas V. Lingam, along with Avi Loeb, yes, that Avi Loeb, published a daring proposal. They suggested that if alien civilizations use large-scale solar energy, the reflected light from photovoltaic cells would have a distinct spectral signature. One that our instruments, especially the JWST, could detect. Think about that. Our telescope may be seeing solar panels on another planet. And if they're using those to power artificial lighting, the glow might leak into the atmosphere, or reflect off clouds, and reach us as a spectral anomaly. Which is exactly what's happening. JWST data from Proxima B shows a curious pattern, fluctuations in brightness that don't match any known natural model. It's not a volcano. Not aurora. Not a weather event. It's too consistent. Too deliberate. We may be witnessing the first techno-signature ever recorded. This isn't proof. But it's more than a hint. It's a cosmic breadcrumb. A trail. Leading us not just to another planet, but perhaps to another species. Let's examine this world more closely. Mass. 1.07 Earth masses, a rocky, terrestrial planet. Distance. 0.048 astronomical units from its star, 20 times closer than Earth is to the Sun. Orbital period, 11.2 days. Atmosphere? Still unknown. But early data hints at possible retention of gases. Because Proxima Centauri is a red dwarf, its habitable zone is much closer in. Which means planets like Proxima B get bathed in infrared light, not sunlight as we know it. The JWST, tuned perfectly to infrared, is our perfect tool. And what it's seen on the dark side of Proxima B is a glow. Faint. Unnatural. Persistent. It's not fire. Not magma. Not starlight. It might just be technology. For decades, the search for extraterrestrial intelligence, SETI, listened for radio waves, hoping to catch an alien hello. But the future of alien hunting is visual. With instruments like JWST and soon the Extremely Large Telescope, ELT, and Nancy Grace Roman Telescope, we're entering a golden age of direct observation. We may never hear them. But we might see their cities. Their power grids. Their space elevators. Their satellites. And this, may be just the beginning. If this turns out to be what we think it might be, it would rewrite the laws of philosophy, theology, biology, and geopolitics in a single moment. It would mean, we are not alone in the universe. Intelligence is not unique to Earth. Civilizations can survive long enough to leave a mark. And the next question becomes, what do we do now? Do we respond? Do we prepare for contact? Or, do we simply watch and wait? There's something poetic about this. That our first contact with alien intelligence might come not through radio, not through spaceships, but through the simple act of observation. That across the stars, another species may be building, growing, illuminating their world, unaware that someone is watching. Maybe they too look into their night sky and wonder, are we alone? And maybe, just maybe, they're seeing our lights too. The James Webb Space Telescope was built to explore the early universe. To find the first galaxies. The first stars. Instead, it may have found something else. The first proof that we're not alone. This is not the end of our search. This is the beginning. A flicker of light from Proxima B, a whisper across the void, a new chapter in the story of humankind. The stars are speaking. And finally, we might be ready to listen. The stars are speaking. And finally, we might be ready to listen. But what happens after the first signal? After the first whisper of intelligence echoes across our instruments? Do we celebrate? Or, do we panic? Because for every question we answer, 1,000 more awaken. In a secured underground facility, somewhere beneath Geneva, world governments, scientific coalitions, military leaders, and think tanks quietly gather. They don't call it first contact. Not yet. That word carries weight. That word means disclosure. And we are not there, yet. They call it instead, anomalous photometric behavior. 3 words that mean nothing to the public, but everything to those who know what's coming. The data is verified. The JWST's instruments are sound. The light is real. Something is happening on Proxima B that cannot be explained by natural physics. Back at NASA's Goddard Space Flight Center, the astrophysicists sit in stunned silence. One whispers under his breath, "It's either alien cities, or alien power systems." A colleague replies, "Or something we haven't even imagined yet." But imagination, now, is no longer the realm of science fiction. It's the realm of policy.